Okay, so here is our next video on linear equations. This is chapter 2, section 2 within the Algebra 2 book. And it should be pretty much a review, but let's just go over it. Given the domain values of 2, 1, 0, -1, -2, for the linear equation y equals -2x plus 3, find the range values. Remember that domain represents your input values, and so these are your x values for your function. So in order to find the range values, which are our y values, we're going to plug in each value of the domain into the actual equation. So we're going to end up with y equals -2x plus 3. And we're going to do it for y equals, we're going to do it for when x is 2. And so -2 times 2 is -4 plus 3. We end up with -1. We do it again, same process, but for 1, -2 plus 3, and we end up with 1. Plug in 0. We end up with 0 plus 3, which is 3. Plug in -1. We end up with 2 plus 3, which is 5. And the last one, plug in -2. -2 times -2 is 4, plus 3 is 7. Okay, so now that we have our range values, let's first look at with why do we know that this is a linear equation? Remember, you can identify the equation by the highest power of x. So the highest power of x in this case is 1, so that makes it a linear equation. Sorry about that. Okay, so now we're going to model our mapping like we did before. We put in 2, we got out -1. We put in 1, we got out 1. We put in 0, we got out 3. -1, 5, -2, 7. Okay? Okay, so if we want to graph these points, remember these are my x, these are my x, and these are my y. So the first point is 2, -1. The second one is 1, 1. 0, 3, negative 1, 5, negative 2, 7. And we can draw our line. Put our arrows on the end. Okay? You will notice that this is a continuous function because the points continue on and either up or down, and they're not discrete points. So for this one, find the range values given 2, 1, 0, negative 2, and negative 2 for the domain of the linear functions. So again, remember your domain represents your x values. So we're going to plug those in here. So we're going to plug in 2 for x. So 3 times 2 minus 5 gives us 1. Plug in 1. 3 times 1 minus 5 gives us negative 2. Plug in 0. Sorry. And we end up with negative 5. Plug in negative 1. We get negative 3 minus 5, which is negative 8. And then plug in negative 2. Negative 6 minus 5, which is negative 11. So my range values are 1, negative 2, negative 5, negative 8, and negative 11. All right, so how would we do this if they give us the range values and they actually want us to find the domain values? So same idea. Remember, this is function notation. And so this is actually my y value. So I can rewrite that as y equals x minus 1. And they've given me the range values, so those are my y values. Okay, so now we're plugging in the range values. So will be 4 equals x minus 1, and now we just have to solve for x. So add 1 on both sides, and x equals 5. And you would just continue this process. Notice how each time I'm rewriting the equation, this is very important in terms of showing your work. Making sure you've copied the problem down right, because little mistakes frequently mess up an entire problem. So now I have my x value, so my domain would be -1, 0, 1, 3, and 5. Notice how I just put them in order from least to greatest. And that concludes this lesson.